Hello, grade 10. In this video, I'm going to revise the important objectives that we have learned this week, and I'm going to solve some of the exercises in our worksheet. First of all, we learned about uh, powers and radicals. Okay, we've already explained the powers, the important rules that we have learned in grade 9, and now we're going to talk about the nth root of the power. So n is called the index. This is the radical, and we have here the radicand. Okay, so just a second. I'm going to put the annotate. Okay, and here we have a is 1 over n. So we put the power which is inside over our index. That's our general rule. So this is the nth root, okay? And now we've also learned that if we have an even root and an even root, and we have a positive number, then we have two roots or two solutions, plus or minus 8. But if we have a negative number, then this is undefined. It's impossible. We can't find this solution. If we have odd root, then if the number is positive, is equal to a positive number, and if it's a negative, then it's a negative number. Now, this is a simple exercise where we need to write this number as power, or this radical as power. As I told you before, you put the power which is inside over the index, so we have 2 over 3. So this is how do we change from the radical form into the exponent form. And for example, here, now the cubic root of minus 8 is no longer impossible because it's an odd index. So how do I change this? We know that the 8 is 2 to the power 3, and the 3 cancels the index 3, the cubic root. So we have minus 2 to the power 5, which is minus 32. And we have also here fourth root of 32. This is possible because 32 is positive. So when we have an odd index, you should make sure that what we have inside the radical is positive. Let us continue. These are some properties. So the index is for both A and B. Also, if we have quotient, this is also can be splitted for both. Like for example, if we have fourth root of 16 over 81, the fourth root is distributed among, the numerator and the denominator in this case. If I want to add or subtract the radicals, as we learned in grade 9, they should have like terms. Do you still remember the like terms, the like radicals? Also here, they should have like index if you want to add the radicals or subtract them. So these are, we have here a lot of exercises that you can practice alone, as you can see. So this is our lesson. So and here we have the solution. So if you want to check, you can see them. So that was our lesson. I will share now our worksheet. Let me share the worksheet for you that we have already started. Okay, so here our worksheet. We have here this exercise. We have important exercises. I'm going to solve some of them. Let me share this with you. Okay, so here I'm going to solve some of the exercises, starting from the absolute itself, because our quiz next week will be also about the absolute. First of all, here we have 3 to the power absolute x minus 1 equals 81. So you know that 81 is 3 to the power 4. Okay, so 3 absolute x minus 1 equals 3 to the power 4. Then absolute x minus 1 is definitely equals to 4. How do I solve the absolute? I have two cases, same, okay, same and opposite. What do I mean by same? I put it as it is, okay? So x minus 1 equals to 4, then x equals to 5. Opposite, we have x minus 1. We keep everything in the left as it is, but we put the opposite of the right side. So here we have x equals minus 3. So I have two solutions, 5 and 3. This is, I want you to pay attention to number 3 because you've all made the mistake because you're not figuring out how to solve this. You need first to isolate the absolute. So it should be alone. I already explained this before in our previous lecture. So please, I want you to pay attention to this. So you need to isolate the absolute. First, I'm going to get rid of the 7. We will take it to the other side. So we will get minus absolute 3x minus 5 over 2. Okay, equals 3 minus 7, which is minus 4. And now, oh, sorry, the bell rang. And now I'm going to multiply by minus. So we will get absolute 3x over minus 5 over 2 equals to 4, which is possible. And now I solve it 2 cases, same and opposite. Let me solve one absolute but inequality. Okay, so I'm going to continue. I will take one of them. I will solve this one for you. Also, you need to isolate the absolute. So the first thing, I'm going to take the 4 to the other side. So minus absolute x plus 1 less than 1 minus 4, which is minus 3. And now I'm going to multiply the whole inequality by minus. So I get absolute x plus 1 greater than 3. And I solve it in 2 cases, same and opposite as I taught you before. Okay? Now I'm going to solve some of the exercises and powers. I will choose, for example, I will choose this one for you, okay? So how do I solve this? You have to know that 64 is 2 to the power of 6. So we will have C equals radical cubic root of 2 to the power of 6 plus cubic root of 3 to the power 3 minus 2 fifth root of 32, and 32 is 2 to the power 5. In all of these cases, you can write 6 over 3, which is 2 squared, okay? And here we have plus 3 minus 2 times 2. So we have radical 4 plus 3, which is 7. 7 minus 4 is 3. So we get radical 3. So those are the important things that you have to know. If you have any question regarding the worksheet after solving it, of course, you can ask me. Our QP next week is going to be about the absolute value and the powers and radicals. And anything, if you want, you can go back to our lecture, to our previous video, in order to learn or to remember the important notes.